As Pamela said, this webinar series consists in 3 parts. Today we will be talking the first one with our feet on the ground. Soil is a dense topic, so I prefer to split different topics different days so we can digest it better and also helps to be more dynamic. Today we will be talking about current panorama of soils, what is soils, factor of soil formation, soil taxonomy and diversity, soil quality, and then soil health. Next week, we will be in the second part, and the specific topic will be erosion, soil nutrient imbalance, loss of organic matter, salinization, soil acidity, soil pollution, urbanization, loss of soil biodiversity, soil compaction, and crust. And then the third part will be in October 8th, and we will be talking very interesting topics after knowing what is soil and what are the principal problems that can soil afford. We will be talking about solution and action to take. The specific topic will be holistic philosophy, the difference between restoration, regeneration, and resilience, conservation tillage, contour farming, sediment traps that help to avoid erosion, crop rotation, cover crops, soil amendment like compost, manure, and liming. And then we will talk about nutrient cycling, how to work with waste management. Okay. Before I start a presentation, I always like to share with you a quote. This is a quote of Babadoon and say, in the end, we will conserve what we love. We will love only what we understand, and we will understand only what we are taught. Also, before I start with the formal presentation, I will want to show you some questions that Pamela will show you. So if Pamela, you can share the questions.
Yes. So just to have a little test on where you guys at with the subject, we have created a little poll. So we would appreciate your participation just so we can continue to make this an interactive, as interactive as possible. So right now I'm going to be launching a poll. They're very simple questions, just 3 questions, which Zoelie will be talking about today. So if you don't know the answer, just no worries. Try your best, because that's the idea. The idea is for you to grasp a lot of the concepts that we will be going to be sharing in this poll. So I'm going to be sharing that and giving you about a minute or so for you to answer them. If you have any questions about this, also you can put it in the question and answer, and we will be free to explain again on how does it work. So I am launching the poll right now, if you're able to see it. So the first question being, why are soils important? The second question being, what is soil quality? And then the third question will be, how many types of soil exist according to the USDA, to the US? So yes, we will be putting that up there. If you can take your pick in all of the different questions, feel free to vote on which one you consider would be the best answer to each of them. So whenever you have the opportunity, just go right ahead. Okay, so we have the poll. We already have some people voting. So again, we are just doing this as interactive as possible. So please, whenever you have the opportunity to take your pick in the poll and take your vote on which would be the options you consider would be the most appropriate for each of the questions. So I'm repeating the questions. First one being, why are soils important? We have a couple of options there. Second question would be, what is soil quality? And then the third would be, how many types of soil exist? So we're already about halfway there. We still have a couple more people to go and vote.
Yeah.
I'm liking the group's answer so far, but this is a very knowledgeable group, so it seems. All right, we have a couple more people left that we would like for you guys to take your pick and vote. We still have about 30 seconds, so take your pick. Whenever you have an opportunity, you can vote on the questions. Why are soils important? What is soil quality? And how many types of soil exist? So take your choosing. Zoelie will definitely be talking about all of these things. So we're excited to learn about all of these subjects. All right, so we still have maybe like 3, 4, oh, another vote came in. All right, we're almost done there. All right. So 10 more seconds. Take your pick on the 3 questions that we have. You can vote on them. Alrighty, so let's see what the results are for these. All right, I don't know if you're able to see them. So Eddie, could you confirm to me that you can see the results out there?
No.
Oh, wait, there we go.
Yes, now.
Now we can see them.
That's very
Alrighty.
Yeah. Yes.
Awesome.
Yeah.
So definitely, we have a good group to work with, Zoelie. All right, I'm gonna stop sharing the poll so we can continue with Zoelie to talk about soil. So thank you, Zoelie, take it away.
Okay. Thank you, Pamela. Okay. We need to be worried of the actual status of soil in the world. However, more than worry, we should act. This is how it looks around soils around the world. As you can see, very degraded soil are in darker colors. The status in the Caribbean is very concerning. When we talk about soil degradation, means the decline in soil quality when the capacity of soil to perform a specific service is reduced. So we need to take action yesterday, as soon yesterday. So the pressure of soil functions and land resources has been increasing, not only to produce food, also to grow crops that are used as biofuels, such as corn, soybean, wheat. In fact, 33% of the Earth's soils are already degraded, and it's estimated that over 90% could be become degraded by 2050. This is could become, so if we start taking action as soon yesterday, as I say before, we can make a real positive impact. Why this is so important? 95% of our food comes from the soil, directly and indirectly. We can imagine soil that grow in soil, but also food that came from hydroponics, came with things that are from soil. So soil is very important for our food. So we should treasure soil because it's a non-renewable resource. To have an idea why it's a non-renewable resource, it can take up 2,000 years to produce just 10 centimeters of soil. So can you imagine how long it takes to develop a soil profile with 6 feet depth? It's a long time. So it's a treasure that we have beneath our feet. Soil functions are very diverse, from flood regulation, source of pharmaceuticals such as penicillin, also to storage or cultural heritage. So anthropologists can study our past from the records that remains in soil. So soils are very important to us, not only for food production, they have many soil functions. Soils and human has been connected long time ago. Uh, Healthy soils are key for a healthy life. The etymology of the word human comes from the Latin word humus, meaning earth or ground. So you can see how we have been connected to soil long ago. Also, Adam means red clay. As I say, soil and humanity has been connected. Culture, civilization, livelihood, and health. Uh, Homo sapiens were hunters and gatherers, and then we start domesticating plants. But I like to see that as we learn how to cultivate soils. Uh, Agriculture was the pillar foundation of early civilizations such as Mesopotamia, Egyptians, because they know how to cultivate so they can have more complex societies. Also, agriculture is the pillar foundation of our societies today. So we need to appreciate soils because it's the base of our society. Oh, sorry. I have been talking a lot about soil, but I have not defined it yet. In a short definition, soil is the uppermost layer of the earth crust. It is a dynamic and essential system to sustain life. In a more technical definition, soil is the interface of air, minerals, water, and life. The four major components of soil is water, organic particles, mineral particles, and air. When we think about soil, we usually think about solid, but soil has nearly 50% of pore space, as you can see in this graphic. 50% is pore space that is occupied by water and air. And then the other 50% is solid, like mineral particles and organic particles. This is very important because will help the development of plants so they can grow well. And this varies among soil. Is not a recipe, you know. Some soil will have more air than other in the pore space, so this will varies. But how soils are formed? Hans Jenny, an American scientist, developed an equation where he explained the 5 main factors for soil formation. They are parent material, climate, topography, organisms, and time. We will be discussing each one now. First one is parent materials. Let me drink a little bit of water, sorry. The first one is parent materials. The nature of the parent material profoundly influences in soil characteristic. You can have different parent materials that are residual. Those are parent materials that develop in the same place. So when you see a soil, the parent material is from the same place. Also, you can have parent materials that are transported from another side, such as colluvium. Those are soils that form from detached rocks. Another is alluvial. Those are soils that are formed by sediments that are transported by water, by rivers. And also you can have soils that are formed by coastal sediments, organic materials, or aeolian, that are particles transported by wind. Different rocks could be parental material. Three principal rocks are mainly described. Those are igneous rock, metamorphic, and sedimentary. The first one are known only as volcanic rocks, and they can be classified as extrusive or intrusive. Extrusive are those rocks that form on the surface. Meanwhile, intrusive are those rocks that form from magma inside the volcanic activity. And metamorphic are rocks that form from another rocks and are subjected to high heat and high pressure. That's why you can see the lines like when occurs the collision and the high pressure beneath the rocks. The third type of rocks are sedimentary, and as the name says, they form from sediment compacted and cemented. So, how rocks turn into soil? As they go breaking into small pieces, rocks suffer a process that we call weathering, creating small particles that we make the architecture of soil. This is an example of soils that have as parental material igneous rock, volcanic rock. This is granite that is intrusive, and this is basalt that is extrusive. So as you can see the difference between both, granite, you can see the different minerals in the rock because the magma cools slowly, so mineral can get together each other. But in basalt, the lava cools very quickly, so minerals cannot rearrange together. This is important because as you can see, the rock here, when this break into small pieces, granite form biggest particles than basalt. So soils that are formed from granite will be sandy soils. Meanwhile, soils that are formed from basalt will be more rich in clay particles. So this gives you a lot of information of how particles will be in the soil. Bahamian parent materials are limestone and Saharan dust. Limestone from Bahamian are young and very pure. These make soils very alkaline with a pH above 7. And Saharan dust is considered very important because give like more fertility to soils. Otherwise, Virgin Island parent material are volcanic residuum, giving soil a mixed mineralogy, and are formed from coastal sediment that underlie by volcanic bedrock. Soils with the last one parent material tend to be loamy and have higher agronomic value. Okay, we have been talking only about the first soil formation factor. Now we will talk about the second one, that is climate. This is the most influential of the 4 factors acting on parent material because climate determines the nature and the intensity of the weathering. The weathering is the breakdown of the rocks. Some of the some of the, I forgot the word in English.
Can I help you?
Parameters, sorry. Yeah, ahí llegó. Some of the principal parameters of climate that influence soil formation are precipitation, because water will be like the car that moves leaching materials. Also temperature, because with an increase in temperature, reaction will be more faster. And lastly, natural vegetation, because according the climate, will be the natural vegetation of a zone, and this will this is another soil formation factor that we will be discussing, the vegetation. The third one is topography. This describes the difference in elevation, slope, and landscape position. This is particularly important because the position of soil in the landscape will influence the filtration, erosion, and susceptibility to erosion. As you can see in this graphic, if you have soil that develop here where it's more slope, those soils will be more susceptible to erosion than the soils that are formed here. And soils that form here will be deeper than those that are in this position of the landscape. This is because soils that are here will be getting all the material that are eroded, so they will be more rich in particles and be more fertile. That's what tend to be. The fourth formation factor is living organisms. This factor includes vegetation, as I said before, also the organic matter accumulation, biochemical weathering, because weathering not only occur physically with the breakdown of rocks, also occur with the acid that leach roots of plants. So organisms help to the breakdown of rocks. Control of soil erosion, and also they help to nutrient cycling and other stuff. And the last one, soil formation factor, is time. Time is key for all the other soil formation factor can interact each other. Soil formation takes a lot of time. So when we call young soils or mature soils, it is not referred to age in years. What it means it is the soil is very developed or not. So young soils are not very developed. Meanwhile, mature soils are more deeper and developed. Okay. So in this graphic, I show you how is the soil formation along time. As you can see, we start with parent material and then start growing plants and weathering occurs. And then soils is more deeper and deeper and can grow another type of vegetation. So a fancy word to say soil formation is edapogenesis. Soil have layers known as horizon. As you can see in this picture, you can see one layer here that it's brown and the other one is more darker. Not all soil profile you can see layer so easy. This is another soil profile, and as you can see, looks very similar, but the lines divide different horizons. The arrangement of these horizons in a soil is known as soil profile. When I talk about soil profile, I am talking about all those layers together. Okay. The most important layer in the soil profile for an agronomic perspective is the topsoil. This is the surface horizon. This horizon is very susceptible to management, and it's very important because it's where mainly roots system are, and also because it's where most of the biological activity occur. So this is very important because if you over tillage this horizon, you will be mixing with the subsoil, so you will be losing some nutrients that are in this layer. Sorry. According to the soil taxonomy and soil classification of the USDA, as you answer in the question, we have 12 orders. Those are helisol, aridisols, schistosols, spodosols, andisols, vertisols, multisols, oxysols, mollisols, alphisols, insectisols, and entisols. We will be talking about them, not all, because there is a lot of information, but I include them in the presentation, so you can know them later. Okay. The soil taxonomy hierarchy have 6 categories. Order is the main, as I mentioned before, and series is the more specific category. Series provide you a lot of information. Agent visit your farm and provide you the name of soil series that you have in your farm. You can obtain a lot of information just with the soil series name. Now I have a little bit of information of each order. The first one are entisols. Those are soils that have poor development. It's an extremely diverse group. So soil productivity varies. You can have some series that are very productive in agronomic perspective, but others that are not. This order can occur on construction sites because if you use a bulldozer in your farm, you will be mixing all the layers of the soil profile, so you are destroying those soils, and it's like a restart. So this is terrible because you are already losing what nature formed in thousands of years. So that's why you need to be very concerned if you will use bulldozer or other equipment, where you use them, how you use them. Okay. Insectisols are another order that are John, but they have more development than entisols, are mostly in mountains areas, and they form near the back lobe or shoulder in the landscape position, so they are very susceptible to erosion. In this picture, I have one soil profile of an entisol in Puerto Rico, and as you can see, the layers are just here. All this is parent material that are very consolidated. So the depth of this soil is very shallow. other order is histosol. Those are organic soils. They don't have mineral as parent material. Histosol form in anaerobic environment, what allows the accumulation of organic material without decompose. Histosols are mined to use as peat moss, that is the substrate that we use in germinate trays. Um, and they can be used for agronomic use if they are drained. So if you take out all the water, they are very fertile to agronomic purpose. Arid soils are soils without water. They can be highly productive with irrigation systems, and also people grow xerophytic plants like jojoba or pineapple because they don't require a lot of amount of water. Vertisols are dark soils. They are very interesting. They have swelling and cracking clays, are very fertile, but difficult to work. Farmers call them 24-hour soils because one day they can be very sticky and difficult to work, and then the another day they are very dry. So it's a very problematic soil, but it's good. Molly soil are like the cake because they are very fertile, soft, they are rich in organic matter, have good structure. This is the soil that anyone wants in their farm. Alphisols are strongly weathered, but they are very productive. Then ultisols are uh, very characteristic from the tropics. They have low natural fertility, but they can work well. Uh, Here in Puerto Rico, we use them to coffee farms, to citrus farms, so they can compete with another soils if they have good management. Then oxysols are also tropical soils. They have low natural fertility. They are very deep and very stable because have a good physical structure. Spodosol are the most photogenic soils because they have this alluvial horizon that is very wide because all the clays were leached, so it's very photogenic. Are not used in agronomic perspective. In Florida, they use them for dairy farms, but they have a lot of problems because they are susceptible to groundwater contamination by leaching soluble fertilizers because they are very sandy, so all the water leach over the profile. So, as Caribbean is widely diverse in biodiversity, is also diverse in soil types. In Puerto Rico, we have 10 of the orders present. In Virgin Island, have 5 orders recognized and near 23 soil series. As you can see in the map, there are alphisols, entisol, insectisol, mollisols, a lot of mollisol, that is very good, and vertisols. Oh. So, giving you a perspective of the diversity of soil and why they can be so diverse, because will depend on the interaction of the soil formation factor, we will talk about soil quality. This is a very hot topic in soil science right now. Uh, but what is soil quality? Steven Graber from NRCS defines soil quality as the capacity of each soil to function within its natural or managed ecosystem to sustain productivity, enhance water and air quality, support human and animal health and habitation. And this is not limited to agriculture, but most work and evaluation has occurred on agricultural lands. This means that when we talk about soil quality, we can talk in forests, not only in agricultural land. When we talk about soil quality, we need to understand that it is from a holistic perspective because it integrates physical, chemical, and biological property. Physical property are the soil architecture. Meanwhile, chemical property are like the bank because it's the nutrient availability. And biological properties influence dynamic and cycles. Talking about some physical properties, let us start with texture. Texture describes the size of soil particles. You can have, soil have three size of particles. The first one is clay, this is the smallest, and then silt, and the biggest one is sand. So sand is not only what we found at the beach or river, sand is a particle size. Texture is a critical topic for understand soil behavior and management because if you have a sandy soil, water will infiltrate very quickly. Sandy soil doesn't have the capacity to hold up large amounts of water. And if you use fertilizer, you need to take this into consideration because you will lose what you apply if you apply in biggest amount. Oh, sorry. And texture is a basic property of soil. You cannot change texture. This depends of the parent material. There are 14 soil classes. We use this triangle to determine the soil texture classes, and it will depend of the proportion of the particle size. Okay, as you can see in this graphic, this is the behavior of water according the texture of soil. If you have sandy soils, water will not be available because will leach very quickly. And if you have clay soils, they will storage more water. Loamy is the best textural class because you will have a soil with good infiltration rate, but also you will have a soil that has the capacity to storage water for plants. But you can work with whatever soil you have. All soils are good. Another physical property is soil structure. This is the arrangement of sand, silt, and clay particles, but also the organic particles. Particles become together, aggregated together, and form the what we call aggregate. This will influence the movement of water, and this is a soil property that you can change with management. How you can change soil structure? Adding compost, because compost will help to bind together the particles, so will improve the structure of soil. But this takes time. It's not from one day to another. Another physical property is soil density. Soil density indicates how well is distribute soil volume. Remember that you need a soil with pore space. So this pore space can be occupied by water and air. So plants need air and water. So when you have a low bulk density, you will have enough for space for plants, but when you have higher bulk density, this means that particles will be attached each other, so pore space is reduced. This is a good property because can alert you if you are having change in soil quality. Because if you are getting more higher bulk density over time, this indicates that you are deteriorating your structure of the soil. So give you like a window so you can take action. But in this graphic, I want to show you that soil density will get more higher when you go deeper in the soil. This is naturally. So you want a bulk density between 1 and 2. It will depend on the soil texture. Sorry. Infiltration is another physical property important. This is the process by which water enters to the soil pore space and become soil water. When it becomes soil water, this means that it's available to plants. And as you can see here, if you have good structure, water will have good infiltration, right? But if you don't have a good soil structure, this means that water will go over the surface and will create runoff, and you will be losing soil through erosion. In this graphic, I want to show you that infiltration has variation and will depend on soil texture. If you have a sandy soil, you will have a very quick infiltration. But if you have a clay soil, infiltration will be more slowly. This information helps you to know if you need to make like infiltration trench in your farm. We will be explaining what is infiltration trench in the third part of this webinar series. But this is good to know because you will know how to act in your farm when a lot of rain comes. So now we will talk about chemical properties about soil quality. Let me see if I am doing well with time. Okay. The first one is pH. This defines the condition of the soil, if it's acid or alkaline. Acid soils are those that have a pH lower than 6, and alkaline soils are those that have a pH over 7. pH is a measure of the activity of protons, and it is considered as a master variable because will influence other property of soil, such as nutrient availability. As you can see in this graphic, those are nutrients that are needed for plants. So when the lines get thinner, it's because this nutrient is not very available to plants. So you can see that between 6 to 7, almost all there are available to plants. So this is a key property to agriculture. This is a graphic that explains how pH affects some nutrient or element in soil. At the left, we have how aluminum comports according to the pH of soil. If you have a pH lower than 4, you will have aluminum in toxic concentration. But if you have a pH with near 5, you will not have aluminum in toxic concentration for plants. At the right side, we have another graphic that explains how phosphorus comport in soils according to the pH. If you have a lower pH, phosphorus will be attached to clays with yellow ferrous. And if you have pH higher than 7, phosphorus will be attached to calcium. So this will affect how phosphorus is in the soil, because if you have a pH near 5 and you are fertilizing with phosphorus, this phosphorus will not be available to plants because you need to enhance the pH, liming or adding compost. Another soil chemical property is Cation exchange capacity. This is the capacity of the soil to hold cations. Cations are essential nutrients for plants, and this is a basic soil characteristic, is an inherent soil characteristic, so you cannot change that. But this is proportional to soil organic matter. So if you add compost to your soil, you will be enhancing this capacity. So you will be providing to the soil the capacity to provide nutrients to plants. Okay. For example, if you have soils of the multi-soil or vertical order, those soils have negative charge. Meanwhile, soils from the multi-soils or oxysoils order have more clays with positive charge. So this soil will have better cation exchange capacity than this other one. This is important to know because this will tell you how to do your management in your farm. Let me see. Now we will be talking about some biological properties. Okay. Soil is alive. Over decades, soil has been treated as a substrate, as inert material, but soils are alive. As you can see, there are more soil microorganisms in a teaspoon of healthy soil than there are people on the earth. So can you imagine all the life that healthy soil has? Soil microorganisms play essential roles that benefit us. In an agronomic perspective, mycorrhiza has been widely used to enhance root system of plants. Mycorrhiza are symbiotic relationship between fungi and plants. They work as a station of root system. As you can see in this picture at the left, it's a root system without mycorrhiza, but at the right side, you have a plant that was inoculated with mycorrhiza. So they work as a station from the root system that benefit the plant. In addition, let me drink water. In addition, soil microorganisms helps through nutrient cycles. The microfauna in soils are bacteria, fungi, algae, actinomycetes, and lichens. For example, if you use urea as nitrogen source, as fertilizer, microorganisms will make that urea available to plants. Also, if you use legume plant as cover crops, bacteria of the group Rhizobium will help to fix atmospheric nutrient to the soil. This is what you can see in this picture. Those nodules are from the bacteria that are fixing atmospheric nitrogen to the soil. Also, the microfauna produce binding compounds that help to the aggregate stability. So they are very beneficial. Mesofauna are biggest living organisms in soil. They facilitate the composition. As you can see in this picture, at the left side, you have soil and oh my god, I forgot the word. A leaf without earthworms, and at the right side you have soil and with earthworms, so they facilitate the decomposition of those material organisms. They have a direct effect on the soil structure because they create biopores that helps to the infiltration and to create more pore space in the soil. Also, mesofauna helps to control pathogens as Beauveria bassiana that is widely used as control for pests. So some organisms are identified as soil engineers because they had a great impact on soil property. We have three groups of soil engineers. They are ants, earthworms, and termites. So as you can see, soil quality relies on physical, chemical, and biological property, all working together. Soil quality looks as an ecosystem, not only with agricultural purpose, but when we talk about soil health, we talk in more agricultural perspective, but we are looking more for biological properties. Stephen Graber from NRCS defined soil health as the condition of the soil and its potential to sustain biological functions, maintain environmental quality, and promote plant and animal health. So, soil health is an evaluation of soil according to symptoms and signs. It can be measured directly, but you can use indicators. Those indicators need to be easy to evaluate and reflect changes in soil functions. Indicators must be sensitive to change in weather and management. Why? Because you want to know before it's too late. So when you are evaluating soil health, it's good because you will know if something is working or if something is not working. Some symptoms of change in soil health that need attention are crop physiological change, poor plant development. If you have a crop that you grow already over time and you are watching that the crop is not doing well and you are doing the same as always, maybe it's time that you look for your soil health. Also, root atrophy, if you see discoloration in plants that are not deficiency of nutrients, if you have low yields, and also if you see few organisms. For example, if you over the time uh, are not watching earthworms or other activity, this can be a sign that your soil health is needed attention. Um, Signs are visible expression in soils. As you can see, symptoms are in crops or in living organisms in soil, but signs are visible expression in soil. Meanwhile, uh, you can see if soil health is deteriorating, if you see that your soil is compacted, have poor infiltration over the time, if you see that your soil is cracked like this one, if you see that your soil have poor organic matter content. This is important that you do soil analysis over the time so you can make sure if you are losing organic matter in your soil. Also, if you have poor structure, if you had a granular structure and over the time you have like a compacted structure, this is a sign that you are losing the soil health of your farm.